Today we have a very interesting talk in the same line that we are been dealing with these last weeks in the sense that, we are in the block 3 of the program. We are in signals, receivers, processing, acquisition, tracking, loops, and these kind of things. And I think the best for explaining all these kind of things, and in particular what is related to attacks, vulnerability, resilience of the signals in front of threats like spoofing, jamming, cyber attacks, and so on. I think we don't have any better person to explain this than Gustavo Lopez. He's here in the top left corner of the screen. He's the market access manager in Septentrio. Septentrio is one of the best companies in receiver manufacturing. Maybe, as you know, Septentrio is a brand very famous in the market for every single kind of applications that you can imagine. And this is not the first time he's here. He's like 3-4 times already. He came into Toulouse last year in Grow and also in GSNP, several webinars with the Academy. And we are pleased to have him again here. Hi, Gustavo, how are you?
I'm fine, thank you. Thank you, Eduardo. And thanks everybody for joining.
Maybe you can introduce yourself a little bit before sharing the screen and so on.
Sure, no problem. So yes, as you were saying, I work in September already for several years. By the way, it's becoming already a long time. It's now 21 years more or less now. So it's indeed already some time in Septentrio. I have a technical background mainly on software. I work in the R&D team for several years in Septentrio, but now I'm working more in the business development, which is a bit more the commercial, but still quite technical side of the company, and bringing, of course, also the strategy for long-term activities of the company. You know? So what are we gonna do in 4 years from now, 5 years from now? And that's why I'm involved in a lot of market studies and talking to several companies in the field place. And definitely some interesting markets that are also related to this topic is UAV and robotics, especially in the UAV side is where we see this problem, a lot of anti-jamming and anti-spoofing. So UAV is one of my top markets actually already for several years in the company. The intention here is to give you some of the overview of what do we mean when we talk about GNSS resilience or GNSS security, which is a topic that is growing more and more. I can tell you maybe 3 years ago or 4 years ago, when you were talking about this topic to companies, people really did not really care so much about it. It was like, okay, yeah, that will not happen to me. But we get to see this as a more usual problem for customers. And that's why, of course, it's quite relevant, especially for you that are studying this topic of GNSS. So that's what I will try to explain a bit of what I mean by that. What are the techniques that are used in order to mitigate some of these problems there? And also at the end, I have a bit of an update on what we have done in Norway, which is a place where we can also do this type of tests of anti-jamming and spoofing. So definitely was a very interesting insight. So you will be kind of the first people to hear about those results, by the way. So so definitely interesting to see that at the end. Yeah. So yes, I mean, why are we talking about security? Here, as general quote, actually, time is what determines really security. I think with enough time, nothing is unhackable, and this is indeed key message here. The same happens for GNSS. So you can have, of course, a receiver that is bringing protection and the better, just like your antivirus today in your computer. But there are always new attacks. There are always new elements of way how to hack the receiver itself. So you need to keep updating that. And this is actually where Septentrio really focuses a lot. You can see already here, I mean, this is actually from the period of 21 to 22. This is actually data from air traffic, and you can already see the amount of jamming events detected by the aviation authorities. This is a report from Eurocontrol, where they monitor all these type of things. Definitely, you can see Europe is not in the best place of the situation right now. We also understand why this is increasing more and more. If you take a look at reports even of 23, this has increased quite a lot in all these areas here. And you can see it's not really only centralized in specific locations of Ukraine, as an example, or other parts in the Middle East. It's actually expanding, starting to be spread everywhere. And this is actually the fact that GNSS is being used more and more, and also people are getting more access on how to hack these type of things. This is another map also with some events actually of jamming. And you can see, I mean, this is actually Denmark, you can see here, so a bit the Nordic type of countries here, and they are also being affected by these things. So it's not something that is only happening in these conflicting areas, it's also spreading to other sites, and this is why people are putting more and more attention to these problems as well. So yeah, before I start with that, so who's Septentrio? Yes, as Eduardo presented, it's a company we focus in high-end GNSS positioning. Really, our main focus is to bring high accuracy, reliability, if we tell you a position, we want to make sure that there's a real, true position behind it, that it works in difficult environments, such as mining, construction, UAVs, hidden, etc. And also the security part is where Septentrio puts a lot of attention, and that's why we have a very strong, at least, reputation in that side of the security of GNSS, anti-jamming, anti-spoofing. So thank you again, Eduardo, for inviting us for this talk, which is a very relevant topic for Septentrio as well. Some of the products of Septentrio, I don't want to sell you products, but anyway, you have some of the products here so that you can check them out. We have all the way products from box type of receivers, which are used for scientific type of applications, call it for geodesy monitoring, seismic monitoring, I don't know, weather monitoring, all those type of things, space weather monitoring, all the way to, of course, applications that are used for industrial automation. So Septentrio really focuses in that high-end industrial automation, which can go from agriculture, construction, mining, and also definitely some of the emerging use cases applications, such as UAV, robotics, space, which is also bringing some of the new LEO type of systems with some of those things we were discussing, Eduardo, before the beginning of the talk. So there are definitely new emerging markets popping up. Defense, yes, defense is also popping up. Unfortunately, there is a side of defense that is also interested, of course, on these elements of security. And yeah, they are sometimes, of course, using also GNSS receivers in order to protect those sites as well. And yeah, you can see the integration can go even to small modules, which can be also put into small drones, which could be quite affected by this type of jamming or spoofing. Yeah. So let's start by what security is actually. What do you think is an onion? So it's an onion, and this is for me how I always think about security. If you want to protect a system, you need different type of layers of security, and you cannot just put one of those layers and that's it. No, you need really to put all those layers to have better protection in the system, and definitely the protection at the core of the GNSS receiver is one of the most important. Sometimes people try to bring the protection at a very high level of the onion side, and that's it, but that's not going to work. You really need the core protection, because then you have more control of those signals, of that analog signal that is in the interference or the hacking that the security system is giving you. So yes, you can see a bit of those onion layers here as an example. Anti-spoofing, anti-jamming, and cybersecurity. I would say those are the main three topics when we are talking to this GNSS security. Cybersecurity, I mean, that we all know, right, is basically what we have in our mobile phones, what we have in our embedded systems in order to be more secure. Luckily, there is a lot of technologies already for several years that protect you in that respect. So we just need to make sure that GNSS manufacturers are implementing those elements of security when they are developing an embedded system, call it Linux, call it operating system, or call it boot system, or anything that is related to those elements there. But you can have also, again, the more related elements of security much linked to the GNSS, which is anti-jamming and anti-spoofing. So I will explain those. I know that you have discussed this already in the past, but I always say to the people and to my interns sometimes, repetition is never bad. So you will always bring that as a good value. Then I talk about viruses, and I think it's a great analogy here. I mean, this is maybe you are too young to know this, but actually there were several viruses started somewhere in 1971, so already quite some time ago. And actually, the first type of viruses were created mainly in a university, thanks to this guy here, and he created the first virus just as a test in the computers itself. And then everybody said, "Oh, that's a great idea," and everybody started to create viruses around it. And this is what happened in computer viruses. Then antiviruses came into the place, and I think most of you are already using an antivirus in one way or another. Sometimes you don't even know that you are using an antivirus because this has become much more of a common practice, actually, even more transparency behind that security. But there is, of course, already quite a lot of awareness in the community behind it there. But what about GPS jamming and spoofing? Unfortunately, there is not such a lot of awareness, as I was telling you. It's becoming more relevant due to the circumstances that I already showed you, more events happening. But still, there is a lot of guidance, basically, that we need to do to our customers about the problem. Because, for instance, if somebody says, I have anti-jamming or I have anti-spoofing, that does not really mean that they are protecting to all this type of viruses or GNSS hacker type of systems that you find there. So yes, before, I mean, actually, this was just as an example here, it was also in a movie. This was kind of the first spoofer, and it came in one of the James Bond movies. So the idea came from there, and then somebody started to create a very simple spoofer in a university there. But of course, this was a fiction that became reality at some point as well. So do we see these problems? I already showed you some of those aviation problems. You can see it here as well. So yes, planes can be canceled due to some GPS jamming at the airport sites, and this has already happened. Here you have an example of that, which is flights in the Dallas area actually were just grounded in order to understand what was the problem, because there was indeed some GPS signals that were not reliable behind it. So this can cause already disturbances in the infrastructure that we use today in different places. And as you know, GPS is used in many other type of applications, including the finance banking that you have in your your money is also synchronized due to timing, and that timing is synchronized to GPS. Your telephone is also connected to cellular networks; those are synchronized by GPS. So there is a lot of worries behind that from the governments in terms of the problems that can happen related to GNSS security side. Could traffic lights stop working due to GPS failure? Yeah, same situation. It has also happened. So it actually happened as well here in a use case that that was in New York. And actually the interesting part here is that there were some cameras that were synchronized behind this, and they were also connected to this light traffic control of the traffic lights. And of course, then it took quite some time before they understood that the problem was linked to some jamming that was synchronizing the timing of all these devices there. So again, the problems are actual. We get to see them more and more, and this is because we get to see GNSS have been present in multiple use cases, right? So that's why there is some concerns from the governments. Some people are even saying, okay, we maybe should not use GNSS, we should use other alternative technologies. But the consensus so far is you still need GNSS, and any extra protection layer, any extra onion layer, as I was saying, definitely will be welcome, especially for the infrastructure side as well. So this is where there is a lot of research behind this type of things as well. So when we are thinking about security in the GNSS system, we have different elements. As I was telling you already, You have the signals where you have this jamming or spoofing, and I'll come back to those main topics there because that's the main intention of this presentation. But you could also have, as an example, some failures in the constellations, in the GNSS signals. No, I don't know if you know, but Galileo had when was that? Maybe 4 years ago or something like that, they had a failure, and suddenly, basically, several receivers out there stopped working just because they decided to make a small change in the signal that they were transmitting. So this is actually also a problem. So you need to have all this intelligence in the receiver to be ready for this type of exceptions that the GNSS signals can bring. But indeed, the jamming or spoofing, I would say those are the more important that we get to see, which sometimes can be unintentional, but sometimes can be intentional. And we see both of them, by the way, nowadays as well. And then you have the other elements, as I told you, in terms of cybersecurity. I mean, inside a GPS receiver, you will have some firmware running on it. You will have interfaces, maybe a web user interface or communication interfaces, call it a serial protocol or a USB cable or an Ethernet connection that is for the internet itself. And then you have the application of the user itself, maybe controlling the robot. So all these are, of course, other elements of security. And we in Septentrio we have to make sure that we do the right diligence in order to protect any cybersecurity concerns of the receiver. As an example, having a secure U-boot or the secure operating system where we are running the algorithms here, or hacking protection in the web user interface that we may have using HTTPS as an example instead of standard HTTP. There are some security protocols that you can bring in order to protect better here these type of things. I mean, it might seem simple or not a real problem, but I can tell you that there have been a few reports, for instance, in the past. If you take a look at cybersecurity GNSS receivers, you will detect that there have been some security attacks also in some of the connected receivers and infrastructure because sometimes they were just quite open. So then people could just change the configuration, access the web user interface, and then basically stop the operation of that receiver. So you need also that security. But again, there are several technologies that can help you here. I will try to focus more my presentation on the jamming and spoofing side of the things here. So what's jamming and spoofing? Again, I think you know it quite well, but let me just repeat it. Jamming is sending a signal that is actually operating in the same frequency bands as GNSS, and it's a stronger signal. So that means you stop listening to the signal, and then basically you stop tracking GNSS receivers from there. Those jamming can be done from this small device. By the way, before it was actually a cigarette lighter type of things, but now because most cars have USB, so people have created some USB jammers as well, which you buy for $20-30 US online. And by the way, they are illegal, so I'm not encouraging you to buy these things. But if you buy this type of things, then you might be creating some jamming. That means you are protected because nobody will track you with your phone. But at the same time, you will be disturbing other devices that might be around. And some of these devices can go up to 2 kilometers away. So some people don't realize of the impact that this jamming can cause behind it. And we get to see this, by the way, often in the transportation market. So if you go to the highways in Europe, the toll system of the big trucks, they are operated via a GNSS receiver. So if they are tracking basically how many kilometers you have via a GPS receiver that is embedded in the systems. So if you just jam it, then the GNSS stops operating, and then the truck can keep working a bit, can keep doing more kilometers, and then paying less fees behind. So this is actually a very important problem for the authorities of transport in Europe, where they are also trying to find ways to overcome the problem there. So this is jamming. You can see how the signal gets distorted in this animation side. And what is spoofing? Well, spoofing is when you send a signal and you pretend to be the original GNSS signal. So you are trying to fool basically the GNSS receiver with other type of data that might take you from the actual trajectory that you wanted to a wrong trajectory there. The interesting part about spoofing is that it can be quite dangerous. I mean, jamming, yes, it's also dangerous, but at the end, your system will most likely stop operating. But spoofing, if you send one drone to a undesired location, that's not going to be very much fun for nobody, right? So while the occurrences of spoofing today are much less than jamming, spoofing is growing and the impact to the users is much higher. So in security, you always have this probability of an attack versus the impact of the attack. So those are the two elements you need to consider in these two hacking of GNSS signals, which is jamming and spoofing side. And the technology also became much cheaper, by the way. So now you have all these type of devices. Also, you just pick up a hacker RF, and you can follow certain recipes and do your own spoofer at home, and that's it. So it has become quite easy for people to do that today. By the way, it was quite used by the Pokemon Go people in order to gain points from one place to another. So I will go now a bit deeper in interference. Yeah. So yeah, how come do we see jamming in the GNSS bands, right? Why is this happening? This gives you an overview of the spectrum of signals that we have close to the GNSS bands in there, and we have what we call the higher band, and we have a bit the lower bands of GNSS frequencies. For instance, you can see here L1 type of frequencies, which is in the higher band, and then you see all the new signals from Galileo and other type of things that are mainly in the lower band spectrum side. Very interesting part is in the higher band. This is, of course, L1 signals, etc., which are operating very close to the bands used by the aviation side. So normally they are very well protected, very well monitored. I mean, nobody wants an airplane to stop using the GNSS. So yeah, as I show you, organizations like Eurocontrol really monitor what's happening here, and now they detect that there are more problems here, but they are not necessarily monitoring the other bands, right? So this type of risk, while it was quite protected, the risk are also increasing here quite a lot because it's starting to give them some issues here and there. And you can also see that, by the way, there are also some other signals, especially used for corrections to obtain the high accuracy, which is normally used in the communication systems of Inmarsat. So sometimes you could also have some bit of interference, maybe because they are very close to the bands here. But yeah, again, normally the higher band is kind of protected. The lower band is basically where we have issues, and a lot of issues that you can see here. So what you get to see here is, as an example, aeronautical systems. So if you go to the airports, you have seen this type of antenna somewhere there. Those antennas are operating basically very close to these frequencies of L5 here, or E5. Or some of the communication mechanisms for navigation, they're operating in those bands. So this could be an unintended interference, actually, that you will see as well happening. Here in the L2, you might also have some other radio localization systems that are also operating there. And then you have this part, which is actually the most common one that we have seen in some of the customer cases, which is actually radio localization systems as well, but also a lot of the radio amateur people, actually. So sometimes you have these people that are having their beautiful radio podcasts and whatever, but they are transmitting it in the frequencies. Which frequencies? Those are the frequencies of the GNSS. So then they start radiating, and of course they start creating some disturbances as well, even if they don't want it or they did not intended it. That's a problem, and of course is always an issue for users and applications that are nearby there. So this is a good example there. Actually, here you can see a radio amateur. So this is the type of equipment that they have, and they start transmitting something, and you can see here how the spectrum looks like, actually, how those signals are being affected. Yeah, you can see it's mainly affecting here the GLONASS L2 frequency itself. So it's quite of a big problem for some of the GNSS receivers, and that can give you some problems. So what are the problems or the effects that you will have in the GNSS receiver? Well, and number one is, of course, you could have some issues with the precision that you are obtaining there and the fixes. So you could have some machines that are moving to the wrong location and then go to an accident or something like that. You could also have the loss of signal itself. So that means you will reduce operation because then you don't have enough availability of the signal itself, or basically you could also have no signal at all, and then you basically stop the machine because there is no signal tracking anymore. So these are the type of effects that these jammers can cause as well. This is an example of jamming. I hope the animation can be seen, but you can see here the setup. The setup is we put a jammer here, and then we put also a bit of signal, by the way, from the sky, and then we just put a receiver from Septentrio, and we put another competitor module here, and you can see in this case, when it says a competitor module, is the black one here, so you can see already how it lost signals. You will see it here again. We enable the jammer, and you can see how the signals immediately go down. And this is actually the Septentrio interface, so we keep locally or fixes. So we have implemented some mechanisms of protection in our receivers in order to keep the operation to the maximum as well. And let me introduce you to Maker Blog, which is actually a hacker that you can find online in YouTube. And he explains you how to make these jammers, by the way. So he gives you a tutorial fully on how you can do this type of jamming and create this in a very cheap way by yourself. So yes, these resources are available for many people, and that's why jamming is becoming also much more of a problem. Here another example. This is again the German, but I think this is now much cheaper now. But again, you can see here, for instance, in a drone itself, so no jamming, you can still operate the drone itself. And then when you switch on the jammer, which is actually this type of signal that is transmitted, then at that moment, basically, the drone cannot be operated anymore because the autopilot has detected that there is some jamming, so it cannot do any more activity behind it. So this is becoming, again, quite important, especially for some of the autonomous systems out there. Drones is where we get to see the major relevance of jamming and spoofing. But also there are other type of applications that are also quite impacted by this. So yeah, many receivers, they say they have some protection. Is that true? Well, as I told you, there are different type of layers of the onion, and that means also different approaches on how to solve jamming. So how you solve it? Well, there are different type of techniques, some at hardware level, some at software level, and some could be using some external verification mechanisms. So hardware level is when you are designing your chipset, your core tracking of the signals, then you have to consider how to make the proper filtering, make multi-frequency GNSS receivers, because the more frequencies you have, the more backups you have. Some protection that you could also bring with some intellectual property behind these things. So you can implement definitely things at hardware level. If you don't do that at hardware level, then you could do some things also in software level. And there are some techniques, as an example, understanding the post-correlation techniques, the AGC gain that you have from the signal, a bit of profiling against the different jammers, and doing a bit kind of AI intelligence in order to detect those things. So yes, there are some software mechanisms you can implement. And many people, by the way, they work it at this level, but they if they don't have this hardware part, these hardware components, then they are also losing big part of the anti-jamming protection side. So yes, definitely, I would say the combination of these things is quite important. And the last one is external verification. You could use antennas. There are some anti-jamming antennas you will find in the market. You could use INS to detect if a GNSS receiver is not operating, then you have a bit of ghosting or extra position thanks to the use of an inertial measurement unit, therefore is inertial navigation system, which could help you for those type of things. So this is other type of techniques you could use in order to protect things here. There are other techniques. Some people are creating some specific devices, and I have seen the explosion of devices, I would say, in the last year, because people are trying to bring more devices and to create some business around this area here. But again, they are doing it at the last step, so it's not the best layer actually to protect the system itself. So yes, unfortunately, there are not everybody solving for everything. As I was telling you, you have different type of jamming. And you can see some of those jammer events here. In this case, it's no jamming, so you can see the signal looks quite okay. But then you can see here how the dB from 20 to 100 actually, and you can see this peak here. So this is actually a continuous wave jammer actually that you have here. Then you could have another type of interference, which is, as an example here, a pulse jammer. So you can see it's really affecting quite a lot the signal here, or an overlapping wideband jammer, which is kind of combining these two techniques of pulse plus CW, or a chip jammer, which is that this chip device that I show you is actually quite an annoying device. You can see how it's operating. So there are different type of jammers, and the hackers out there, they are trying to combine these things in ways in order to hack the system, in order to avoid being detected for sure. So not everybody can mitigate toward these problems, and so that's for sure. When somebody tells you I have anti-jamming, that doesn't mean anything. It could mean that it can protect you with a very strong, powerful jammer, but it will not detect maybe some other type of jammers in the field itself.
You don't have the sounds of the jamming as the.
No, I removed them actually because of the Zoom. I was not sure that they will come in, but yeah, it's I can send you indeed offline. But yeah, it's very cool to see how this. I have some sounds that make a good analogy on how this jamming works as well in the field as well.
Very interesting. Yeah.
And then, yeah, and the other part that we get to see in terms of jamming is the self-interference. And I think this is also a common problem. Many of our customers are integrating GNSS in a very compact way. As an example, a drone. I mean, you can imagine there is lots of electronics put into a small compact system. You have a camera, you have an SD card or memory, you have engines, you have servos, you have telemetry. So there is a lot of other in this case, unintended interference that is coming from your own device actually, and is going to the antenna itself and causing those type of problems as well. So this is indeed a very interesting problem as well. And what can you do there? Of course, you can try to mitigate automatically this type of jamming, but you can also that he can start moving devices around or protect it, isolate it, or do something to better handle those type of events. Maybe you hear now a noise, but that's the noise of actually reflecting what could happen in a jamming effect, which is very similar to when you put your telephone next to a radio as well. And here is a bit to show all those type of scenarios as kind of an overview. So you have, again, unintentional and intentional interference. If you think about the unintentional, then you talk about the self-interference that I mentioned to you, so a lot in your PCB, electronics, etc. But you will also have in-band interference coming from some of those communication devices that I mentioned to you, so those radio amateurs as well happening. Yes, we have certain protection, of course, in order to do those type of things at level of hardware, level of software, and you can see that it can really be an advantage. No? For instance, with interference, we can be 10 times closer to the competition in that side. Out of band interference is mainly for some other signals that are not necessarily in the GNSS bands, but are close to them. Cellular communication is a good example. And I can tell you there are some antennas that actually they are GNSS antennas, but they have not being very well designed, and then suddenly you start to see some interference coming from the LTE or the 4G or 5G communications as well. So definitely indeed a problem here as well. There are other type of systems that were also trying to operate, by the way, in the bands of GNSS, such as Ligado, Iridium, Inmarsat communication systems. So yes, you need that protection as well there. And this is the more complex jammers, which are intentional side. I talk about the chirp jammers as an example. The CW jammers, they look very defense type of oriented, as you can see here. We can be 30 times denial perimeter to those. So we have different techniques and in order to solve for that. And I will say, as I mentioned to you, the multiple frequency, the hardware techniques, and some proprietary algorithms are the key elements in order to protect those type of events as well. This is also, by the way, a technique that we use in a receiver, which is something called a notch filter, and maybe some other systems also call it notch filter, but basically it's just a filter that you can apply when you have an interference. So as an example, here we have this peak of interference. So you could apply a notch filter here in order to remove that interference. You could have that notch filter automatically working, but sometimes you might want to decide to do it yourself in that frequency because you have already, I don't know, an SD card that is operating and giving you a peak there. So you could suppress it quite well in a manual way as well. So this is what we offer in our receivers, notch filters that allow you to do that. But as I told you, you could also do it automatically. So we have what we call the WIMO, which is the wideband interference mitigation unit system, which automatically removes the interference. So it's actually detecting in all the different frequencies and checking if there are some peaks. And if there are peaks, then we remove them, and then we automatically remove interference from chip jammers, from short pulsars, from wideband interference. So this is, again, something that we have implemented in our receivers. And yeah, not all the GNSS receivers out there might have this type of mitigation. Some might, but not all will have this type of mitigation for sure.
It may happen, Gustavo, it might happen that when you are using this kind of jamming mitigations like filters and so on, you are losing information from the GNSS signal, and you can also lose the signal, right? I mean, at the end.
Definitely, yeah, definitely. What not with our WIMO. With our WIMO, we try to keep the signal, which is basically just removing that frequency where it's been affected in order to keep tracking that signal. But yes, if you have another type of jamming attack where WIMO is not capable to work, then you could lose the signal. And that's why the multiple frequency diversity is also an important element here, because then your GNSS system will use other frequencies and it will keep operating.
Mm-hmm.
So as an example, if we lose L2 because of that radio amateur, then we can keep operating in L1 and L5 or other frequencies that we have in the receiver itself. So that's why it's quite important to have multi-frequency receivers for this. I mean, if you go to some of the low-end GNSS receivers, they are for sure the lower end are single frequency. Then you have already dual frequency systems which are trying to use this dual frequency for the jamming, but it's only 2 frequencies, so it's still not enough as a backup. So yes, 3 or 4 frequency GNSS receivers definitely will make a bigger difference there.
Mm-hmm.
And yes, here another automatic type of ways to solve that. We have here what we call an adaptive notch filter. So it's kind of an automatic also knocking down of that filter in itself, of that jamming that you have. And you can see here again the example of the radio amateur. You remember that we had that jamming there. So we immediately mitigate that, and actually we keep operating properly with the GLONASS L2. So in this case, we don't kill the L2 band. We keep operating the L2 band even if we have that radio amateur, but we knock out this specific part of the signal there. And then, as I was telling you, the monitoring part, so yes, we have elements to monitor. Some other receivers also have that, by the way, but I will say mainly high-end receivers that have that mechanism, because you need quite some processing power to output this type of data. So the lower-end receivers will not have a good monitoring elements for that. But yes, it will allow you to monitor the different frequencies in a more detailed way to understand basically what's happening behind this type of things, and to provide you detailed data information of when that jamming occurred, what type of jammer was it, at which frequency it happened, was it spoofing or was it jamming. We also have the same flag, so you need this type of information as an integrator of the application side, so that you can either stop the system or locate the jammer or things like that as well. And well, this is again other type of possible interference issues and how we mitigate it. I will not go in detail, but yes, as I told you, frequency diversity is quite important. That helps a lot, especially with what we call excessive interference in the name, where you cannot automatically mitigate it. Then indeed that frequency diversity helps, or the wide the time variant interference, by the way, because sometimes some of these jammers are starting to play not only with the frequencies, but now they're starting to play with the time. So doing a bit of frequency hopping as well. So there again, our technique of the wideband interference mitigation unit is also solving for that. And again, I mentioned also the electrosmoke, which is a self-interference. And there is where the monitoring, I will say, is where it helps. Of course, the other techniques also help, but people mainly want to do monitoring in their own applications, especially when they are doing this FCC certification or EMC certification, because they need to prove the authorities that their system is according to the radiation rules as well. No? So that's actually for jamming. I will now go to spoofing. I don't know if there are questions on jamming.
You have any questions, guys, on jamming? Maybe at the end now.
I actually have a question. The difference between a notch filter, automatic notch filter, and a WIMO, what's the main difference?
Yeah, so the notch filter is not automatic. The notch filter is something that
the adaptive notch filter.
Yeah, true, indeed. So the adaptive notch filter and the WIMO is, let's say that the adaptive notch filter is still putting a filter in that signal there. The WIMO is using other techniques, not necessarily knocking out that or not necessarily filtering, but maybe doing some intelligent mechanisms in order to compensate for the signal itself. So there is a bit more intelligence in WIMO versus an adaptive notch filtering.
Okay, but both does the same thing, right? Automatically remove the jamming.
They automatically mitigate the jamming. It is correct. Yeah.
Okay.
And by the way, you can in our receivers we have the option to enable and disable this, because sometimes people want to to detect this, and even the monitoring, by the way, it also allows you to see, okay, I have jamming, and this is how it's mitigated either by WIMO or by the adaptive notch filter.
Got it.
But yeah, they're very similar technologies in somehow. But yes, the notch filter, adaptive notch filter, is really just a filter at the moment that it detects just one of these peaks that we have seen in the past here. Those ones here, it detects some of these things, so it puts a filter mainly on some of these things here. You know? But you cannot put really an adaptive notch filter on this one here. You need something more intelligent, or in this one here.
Okay.
So the adaptive notch filter is very good for these things.
For only, very, very narrow signals, and then the other is for bigger. Okay.
Exactly. Yeah. That's why it's called wideband interference mitigation indeed. Yeah.
But the WIMO technology is Septentrio technology based, protected?
Yeah, indeed. Actually, our expert of interference is called a WIN. So we we actually call it WIMO, which is Wideband Interference Mitigation Unit. So it fits very well actually. But yes, it's a Septentrio technology.
That's a software level or it's a hardware level filter?
Both. WIMO is at both level.
Both
Even
level.
actually the other parts are also at both level. But WIMO is much more software. There is much more intelligence in the software side.
It means that they are more implementing in the tracking part, the channels, tracking channels, or
Yeah, it goes all the way to that. So you do it at different levels, from the tracking channels all the way to RAIN type of techniques in order to detect these type of things and to either to suppress them or to compensate them in certain way. Yeah.
but also at positioning level as well. I mean, you mean in the positioning engine or?
Yes, yes. So there is mitigation. There is mitigation here. So, or anti-jamming technology is it allows you to keep position there. So yes, the algorithm of positioning is also doing some anti-jamming, but and that's what I mentioned RAIN there, because that's just a step before positioning side.
Yeah.
But the big part is indeed in the tracking of the signals, analyzing the signals, and then indeed doing something at that level.
When you say RAIM, you mean that the measurements are already, let's say, built by the measurement engine, right?
Yes.
Yeah.
Yes. Yes.
At measurement level, right? Code
Yeah.
space measurements. Try to
Yeah. So they are already built from all the tracking loops. You have all that data, and then you pass it to another algorithm of integrity. Let's call it like that, which allows you to say, "Hey, is that a real integral signal?" Because then you start comparing the signals. It's not only an individual signal you look at. You start comparing the different signals and seeing, this looks suspicious.
Exactly. Very good.
Yeah.
And there are
But
some
there are
techniques as well in the
more
front,
secrets.
in the front end part as well. Are you doing something?
Yeah. But this is indeed in the front end. So that's what in our modules, as an example, we have two chipsets, two main core chipsets. One is indeed the front end part. What you do there is to keep a very clean signal tracking. Many other GNSS receivers try to combine signals mainly for cost reasons. So that's why sometimes the cost differences can be high as well. But then you lose the authentic signal and the possibility to do proper analysis of the signal or filtering.
These receivers that have these anti-jamming techniques are, let's say, it's an add-on that the people have to pay for it, or it's just in the serial. Yes. Yeah.
Today is for free. Well, not for free, but today you get it in the receiver itself. So all our receivers have today the same level of anti-jamming. Definitely Septentrio is bringing better technology in the future to keep improving this. And of course, there are certain things that are more relevant for certain customers versus others, right? I mean, especially in the defense market, those guys want to be protected against a military jammer. But if you go to customers that are operating maybe a delivery drone, maybe they are more, they are not afraid of the military jammers, but they are afraid maybe of the hacker jammers, which are a bit more this type of chip jammers or things like that, no? So there are different type of levels, and that can change indeed how you sell this type of technologies.
Mm-hmm. Okay, thanks. Do you have any other questions, guys? No more question on jamming?
All right, so let's go to spoof. Let's go to spoofing.
Let's spoof.
So let's spoof something, and this is as I was telling you, it's less common, but definitely is quite a dangerous one, because then you can take a vehicle from a wanted location to an undesired location itself. And yeah, I mentioned that it happens a lot in drones, but it can also happen in other places. So even timing is also another place where you could have this type of problems. Because it's not only spoofing the position, you could also be spoofing the timing, because a GPS receiver gives you timing as well. So if you have a telecom tower, you could spoof the timing, and then you could knock out the telecom communication itself. So this is becoming indeed an interesting problem for many other use cases as well. So is it really an issue? Do we see it often? More or less as I was telling you, but first let's try to understand a bit the different type of spoofings that you might have out there. Um, an attack of spoofing will depend really on what is the intention of that person, of that spoofer, what the type of equipment they have, and the knowledge that they might have about the spoofing. When we're talking about spoofing, in generally, is more of a intentional attack. There is also an unintentional type of attack. I will mention it in a minute, but in general, it's much more common that you will see people really wanting to attack a system itself. So that means then, but yeah, it depends again on that equipment and the knowledge. So you have different type of spoofing, and you have what we call non-coherent spoofing, coherent spoofing, cover spoofing, and meconing spoofing itself. And by the way, some of the meconing is the only one that I will say could be an unintentional because it's coming from a repeater, and sometimes a repeater of GNSS signals, meaning that if you have a production facility which is producing telephones, maybe they have a radiator, a repeater of GNSS signals, and if it's too strong, then they could be spoofing also something around. And that we have seen also with some of our customers as well. So it could happen also unintentional, but again, the more type of common attacks is this intentional, which are non-coherent, coherent, and covert type of attacks. So you can see here, normally you have a spoofer, you transmit the signal, and then you could affect the timing, as I was telling you, for instance, from a telecom tower itself, or the position in a robot itself. So that can happen. So let's go to the simplest type of attack, which is what we call the non-coherent attack, which is quite easy to make. And how you do that, basically, you create a sudden jump in position and time of the signal itself. So you can see here in my animation how the signal basically is just growing higher with the power higher. So that means the GNSS receiver will start listening to that signal because it's stronger, and it will just lock into that signal itself. So this is basically the spoofing attack, which is a non-coherent attack itself. So normally it's quite easy to detect, I can tell you, because then you immediately see that there is a very high power behind those things, and you will see that the characteristics of the signal also look different. That's why this is moving a bit here, just to illustrate that the characteristics of that signal will look different than the authentic signal. Then you have a bit more complex attacks, which is the coherent attack. So what happens in the coherent attack? The attacker basically wants to have a signal that is very similar to the authentic signal, and then it takes you very slowly away from it, in then increasing the power, and therefore the GNSS receiver cannot longer distinguish that was a spoofing signal because it looks very similar to how it was looking from the authentic signal. So this is what we call the align to the authentic signal and then drag away or walk away in that mechanism to create the spoofing signal itself. So these are the steps: to align, increase the power, and take over gradually the system itself. So this is a bit more complex to detect there, but there are mechanisms also to solve it. Then you have meconing attack. Meconing can be quite a nasty one here. What happens with meconing is that the spoofer is tracking authentic signals from the GNSS receivers and is retransmitting those signals, but with modified parameters. So in this case, it's not a replay of other signals. It's actually real signals that are just modified in real time, and therefore the GNSS receiver sees those signals and they look quite authentic because the system, I mean, this is quite difficult to distinguish those from the authentic signals itself. Of course, the complexity of this type of spoofers is much difficult. But yeah, as I told you, meconing can also happen in the factories when somebody's testing GNSS or mobile phones and they are testing the GPS reception. They put a repeater and of those signals, and then it can create some meconing, but that will be more limited to certain areas. But if you have a stronger spoofer with bad intentions, that's definitely going to be quite difficult to detect. I told you all started with James Bond at some point, so he, he had a picture around that. And you can see here, I should extend my timeline. I think, yeah, the next slide gives you a bit of the timeline, but you can see a bit how the first attempts also from the university started to come. Some of you might know Dr. Humphreys, and he's great in terms of spoofing everything. So if you want to know anything about spoofing and jamming, just go to his papers. He has lots of papers around these things, and he managed to spoof a military drone actually himself, and demonstrated that to the authorities, basically creating awareness that there is a lot of importance to be done in the use of GNSS side. And the incidents are growing more and more. You can see some of that starting to explode more and more in 2020. This I have it updated in 2022, but if you take a look at 23, you will see much more spoofing attacks happening as well in real use cases, and people being affected as well, not only in the military side, also in commercial application side. So this is how we will create a spoofer. I give you $200. You buy, you have your PC, and then you put some software, which is called software-defined radio. You download it, by the way, it's in GitHub for free, so you install it. And then I give you the $150 here so that you can buy this Hacker RF, which is basically kind of a retransmitter of signals, creating the RF signal itself. And basically you create IQ samples that at the end they will create kind of an RF signal, and therefore you will have a spoofing behind it. I'll make it cheaper. So if I can make my spoofer much cheaper, and I just have here a $5 spoofer, because I can create that just using a USB to VGA dongle, and that could also be used actually as a wire antenna system to create a spoof inside. Okay, that might be having a smaller location, but it's possible. And you can see here an attack. This is actually a test where we just have that SDR type of spoofer. We enable it, and you can see that the location suddenly in the right moves to the Everest. And we were not in the Everest, we were actually in Belgium. So yes, it's quite possible to make this type of attacks in a pretty simple way, actually, as well. So no, we had nobody in the top of the Everest, unfortunately. And you can see here this also happening. And this was a very interesting detection of spoofing that was called the circular spoofing, which is becoming quite common sometimes as well. But you can see here that suddenly a lot of mobile phones started to report position in a circle here, and actually, of course, it's impossible to have those type of mobile phones quite aligned. So this was for sure a spoofing attack. The interesting part is that there was an accident, by the way, at the same time or in the same period, actually. So there are rumors whether this was caused by the same type of spoofing, because, of course, ships are also using GNSS quite often for navigation side. So of course, authorities sometimes did not want to go deeper into this case in Shanghai as well. But yeah, we get to see this type of attacks. Here is another hacker. This is Mr. Crazy Danish Hacker, that's his name, which is also creating this type of devices and giving you the recipe on how to create a spoofing system. So yes, you can see here he says we can create a GPS spoofing on a global scale quite well. So again, the technology is quite accessible now to most people out there, and that can be a problem. So how can we detect it? How can we protect against it? This is the Hacker RF that I gave you. So this is kind of a $150 US, but you can have different type of spoofer systems, and you can see some of those here. As an example, if I have a simulator, GNSS from Spirent to the simulator, that can be, of course, quite powerful spoofer because it's trying to be as authentic to the signals there. But of course, a simulator is quite expensive there. But yes, these type of devices are starting to be used more, especially in the military type of spoofing parts as well. And how we detect it? Well, we make the analogy of the Mona Lisa. So you can see here the Mona Lisa, kind of different type of Mona Lisas. So if you have an SDR, at the moment when you are creating that signal for that Mona Lisa, it's not looking as authentic. So we can detect that. We can take a look at that picture and then we see, oops, really, that doesn't look like the Mona Lisa, no? Or you could have portable simulator, starts to look better, yeah. Or you could have this advanced simulator and then, okay, it looks very authentic except for certain small features here and there that you could possibly detect there. So you have to be very careful because this detection is quite difficult. And this is, I would say, where people are right now failing a lot in terms of the proper detection of this spoofing. There is a lot of false alarm detection or not even detection at all, by the way. But yeah, this is where you have to be careful because it could be that the Mona Lisa was upside down, but it's actually the authentic Mona Lisa. So this is where you have to be very careful on the reliability of that flagging. So how we protect, this is again the onion level here. So yes, multi-frequency or frequency diversity that we already talked in anti-jamming will also help us here because if you spoof one frequency, then we have other frequencies to protect against. Heuristics, so lots of detecting those Mona Lisa features and small changes on the picture itself. That's basically what we do a lot in Septentrio. We run more than 30,000 data files every day today in order to detect inconsistencies of signals and to adapt our firmware properly in order to make sure that this is a proper algorithmic detection. So there is quite a lot of intelligence here. You could call it kind of AI mechanisms here in order to detect those type of patterns. Cryptography is definitely, I would say, mathematics normally never should fail, but okay, sometimes it might fail, by the way, but normally Galileo is implementing OSNMA as an example, which is bringing you cryptography. That means that the satellites are sending some authentication in order to say, yes, I'm really this satellite, so you can definitely trust me. So this is what we use a lot in our receivers as well. We have that implemented properly. We have OSNMA. Unfortunately, OSNMA is today only protecting for Galileo, by the way. So that's a bit of a problem here. But you could use other type of techniques also for spoofing, either inertial INS, as we discussed also in jamming, but you could also use other satellites. For example, in Septentrio, we are using another constellation, which is called Fugro Atomicron, which is a constellation of communication, but they can give us information about the satellites, precise information about the satellites, and there is also an authentication of all those signals. So with that, we can not only authenticate Galileo, as is with the case with OSNMA, we can authenticate all the constellations. So this is very interesting as well as a protection mechanism. So these are the different levels, and just to show you a bit how we test some of those things here, you can see here a spoofer. This is the SDR spoofer connected to a receiver, and then we try to do some detection. You can see this is our web user interface. We definitely detect that there is spoofing, and yes, we don't give position to the user at this moment because it's been spoofed, so you cannot necessarily give a position here. So we tell the customer, hey, better no position than a bad position. You could go to a more complex spoofer, which is the simulator itself. So the same situation, we detect those Mona Lisa type of thingies that might still remaining, and we can also detect that. Yeah, again, the authentication definitely will also help, but other mechanisms of multi-frequency and the algorithmic heuristics will also help you here. Now, what if the simulator solves for those anomalies and again, we have cryptography. So we can always take a look not only at the picture itself, but at the signature itself. So that's what I was telling you in terms of OSNMA. That's what they are doing. They are sending us this authentic signal. It's authentication of signal, and that's what we do. Normally, the initial service already started in 2023. They did some modifications. I don't know why they did that, but they did some modifications, unfortunately, and they
Change
sent an
everything.
ICD. Yeah, so it's a pity because of course many people were already using the service behind it. So yes, they changed the signal ICD, but yes, this is already kind of operational. Let's say like that. It's already usable as well. So we have all receivers that are integrating those OSNMA
We
systems.
have to say that the OSNMA is protecting Galileo signals, but only the navigation message data, right? Just what we are authenticating is that the data is coming from the real Galileo satellite, but you are not authenticating the signal itself, let's say the pseudo ranges and so. That's for this, we have another service that will be coming soon. I think in a few years, it will be the commercial authentication service or the signal authentication service that is already being put in place, and it's called ACAS now, ACAS, Assisted Commercial Authentication Service, and will be completing this OSNMA. And also we have to say that in the future OSNMA evolution, we are planning to also to authenticate GPS signals, GPS navigation message, right? You are aware about it, right?
Yeah, that is correct indeed. And this is indeed going to take some time, but yes, that's definitely the case. By the way, it's not only Galileo. The GPS people also are working on Chimera, that's the name, or Chimera,
Yes.
I don't know how they pronounce it,
Yeah.
which is even a more advanced type of encryption that they have on these things, which is going to be a problem because not everybody will be able or capable to run that in GNSS receivers because we are talking about authentication, which is quite some algorithmic in order to decrypt this type of things as well. So you need also a reliable, powerful CPU. OSNMA is a bit simpler, but Chimera might be more difficult. CAS is also, it will require some extra powerful CPU as well. But you can see that indeed the power of OSNMA. So you can see here it's been authenticated as an example in the receivers. And you can see here the satellites that are being authenticated in some of the parameters from the user interface of a receiver. So yes, it's definitely usable. And if you have an attack, as an example here, we try to fake basically a spoofing attack. We detect it. So OSNMA has detected that thanks to that authentication itself. So it does work. So that's for sure. It does its job. There are ways to hack it, by the way. So OSNMA might not be perfect. As I told you, everything is hackable in this world, including OSNMA. But definitely there is already much better protection in GNSS systems as well. No, so. And as I mentioned, same for jamming, spoofing, there are also different quality indicators we have, and you already saw some of those, which help you to monitor, is there jamming, is there spoofing, what type of jamming, what type of spoofing, so all those type of things are implemented. And normally the type of recommendations we tell to our integrators is, okay, use OSNMA and monitor that. So if you have that, then you can use the system itself. If you have the spoofing, then switch to other mechanisms of PNT or position navigation timing, because this will happen still in several occasions. No? So we want to make sure the Mona Lisa is happy at the end out of these things. Yeah. And this is the last part. I'll try to go fast because it's pretty 8:16, but I'll give you an overview of the last test that we have done in Norway. What happened in Norway? Some of you might have heard about it, but there is every year there is something that they call the Norway Jamming Test. They call it the Norway Jam Fest, where you can see that it happened in the middle of nowhere, actually in an island somewhere from Norway itself. So it was quite difficult to get there. And this happened in September. And the goal was basically to invite the industry and to create some real jamming and spoofing effects in this island, where people could come with their equipment and test their systems. Yeah, so this was a great event. Several companies participated there. Surely Septentrio. We did not participate in 22, by the way, when it started, because we got invitation quite late. But now definitely we intend to participate not only this year but also in the future. Yes, this is definitely something very relevant for us. So what they do there, well, hopefully you can see the location there. So it's really in the middle of nowhere, of course, because they are creating quite some jamming and spoofing there. But what is it is basically a large-scale civilian testing that they are doing, and they have, again, different type of scenarios for jamming and spoofing, with quite some powerful equipment, by the way, there, in order to do this type of test. You can see a bit of the equipment that they use there. So it's great for us because this is real authentic scenarios, real authentic data with different type of systems. So it helps us a lot to improve our products behind it, and to validate and to continuously improve our systems as well. So this is kind of the setup, at least for the Septentrio point of view. We had, of course, different type of Septentrio receivers in order to test the system itself. We also have some competitor receivers, as you can imagine, and we also record data. So we can record data not only from the track data, but even the analog data itself. So we have a recorder so that we can replay this type of data as well for future use cases as well, in order to improve those algorithms there. And you can see a bit of the equipment, of course, that is here as well. So quite powerful systems. And just a bit of pictures, basically. Did we mitigate jamming? Well, you can see that that's the case. Actually, we have a 99.5 position availability, actually, from the results itself. I must say that actually the jamming that they did was quite powerful, and they had very strong jammer. In that case, it was not so difficult to detect the jamming, but yeah, in certain receivers were even actually knocked out immediately and not even able to give a position or tracking actually from the system. You can see here how did we do versus a bit of the competition as well. We did a bit of kinematic scenarios as well. In a test itself of a car, and you can see here basically how Septentrio keeps the signals tracking, while many other receivers basically they lose the signal completely. So we have a good protection, you can see, from our receivers. And then we do the same for spoofing. As you already know the techniques, we have multiple techniques that we use for anti-spoofing side. So we also have tested that. You can see here the results. Very, very interesting results. You can see basically that Septentrio is detecting quite reliable the spoofing events, while indeed
the second one's what is the brand?
That I cannot tell you for fair reason to the competitors. But yeah, there are some, to put it here, there are some receivers that are high-end receivers here that are tested. And let's say that there are two high-end receivers here and one lower-end receiver. So that will give you some hints of that. So even the high-end receivers have problems, by the way. So it's definitely of a big problem as well.
Good.
So yes, it's definitely very interesting to see that we have the protection, while the other ones indeed are not really protected, especially for the spoofing, or they might have flags that are definitely not usable at all. And you can see that also here in this kinematic scenario. So you can see here how the receivers basically, this is one competitor A. You can see basically the spoofing was following it exactly as it was, so no other problems behind it. In this case, the competitor B just started to go crazy about the position itself, and then you can see competitor C also fully crazy. So Septentrio kept the route basically quite well. So it's very nice to see the results out of this test as well.
It means,
Um,
I mean, you don't only detect spoofing, but you keep the right position.
Yeah, exactly. Well, when possible, indeed. Spoofing mitigation is something I will say that we are just starting to improve in a better way. We have already mechanisms of mitigation, but where we have invested more is mainly on the detection side.
Yeah, but in this particular case, the spoofing it was in
Yes.
in one satellite, right? Or
Yes.
yeah,
Yeah.
only one satellite.
So in this case, indeed, it's quite, at least for us, we could actually compensate
You
very
use
well. And
you use like RAIN techniques, as you were explaining, right? In order to detect the.
indeed, different type of techniques that we have. I I had that chart in another presentation, but we have basically the use of all this, what I told you, which is heuristics, cryptography, and multi-frequency diversity. And there you can see when you switch on or off some of these ones, then you see the value that they bring. You need a combination of all these things. So this was very interesting results also for us in that respect.
But this kind of spoofing was like simulating spoofing, or was
No. This is real spoofing. it's it's
it's
it's,
a
it's
real spoof of a recorded and replayed, right? Recorded and
yes. It's using this. I think this is part of the equipment that they use, but it's quite a simulated spoof. So it's using the expensive type of simulators in order to create a very good spoofer as well. But they did coherent, they did non-coherent attacks, so they did a mix of all those type of scenarios. They combine jamming and spoofing because that's what happens also in reality. So so yes, yeah, it was very interesting for us. Did we fail somewhere? Yes, we detected, of course, that there are improvements to be done, right? I mean, you can see here we have something undetected, so yeah, we want to improve those things. So yes, this is again kind of taking me to my conclusions, which is there are different type of techniques for jamming and spoofing. We have discussed those. The adaptive notch filtering, the WIMO, the frequency diversity, authentication from SNMA, chimera, diversity frequency also for spoofing. But at the end, you need to keep improving the technology, and this is where really we put an emphasis to protect those things. Um, so yeah, I hope that gives you an overview. Security is a process, not a product. So keep adding layers to your onion. I think that will be my last word of this presentation. So I
Thank you
don't
so
know if there
much.
are questions.
Thank you so much, Gustavo. Very, very interesting.
Sure.
Do you have any questions, guys? Spoofers. How many spoofers? This is spoofer.
Yes, it's spoof.
I'm not a spoofer.
It's a jammer.
So thank you, Gustavo, for the talk. I've got a couple of questions. The first is you said at the beginning that with time everything is unhackable, but it looks very difficult to be one step ahead. So is there any research department at Septentrio or something that can be implemented just in case something happens, or you need to wait until it happens and then you start implementing your
These things. No. We do. So this is, I think, for Septentrio in terms of research, this is one of the big activities I will say we have. Although I would like other activities in research, I think this is really where we put our big effort, and we have good people doing that. And luckily there are customers behind. So there are customers that want this to be improved. And therefore we need to do research in order to bring that. Right now, there are things that we can do to get ahead of the market, of course, on this side. I mean, things will happen. Leo constellations, as an example, is one of the topics that is coming up. Artificial intelligence, I mentioned it. Today we are not necessarily using it. It's kind of an old-fashioned artificial intelligence, but you can do other things with the new artificial intelligence. So this is definitely activities of research. And then the other part that that we keep working also is localization. I think this is something that we get to see much more demand as well. People want to localize where is the jammer, where is the spoofer. We already give the information, by the way, to have this, but people want to pinpoint in a more accurate way where is this coming from. So there are areas definitely of research that we keep working on and to stay ahead of that. And yeah, then of course we also have the hacking happening in close to the conflicting areas that we know about, Ukraine, etc. So even if you go to Romania, you go to Poland, you see this type of thing. So it's quite easy to just go there, record the data, and you will see that the attacks are not anymore the traditional attacks. They are really becoming quite sophisticated.
Thank you.
Mhm.
Any other
And
questions?
I had a second question if
Sure.
nobody else. Maybe it has nothing to do, but do you need different techniques or approaches depending on the country? Like, for example, US, if there is a waiver, you have less constellation, or in China that they have more
Mhm.
restrictions, laws, or maybe they want to use only Baidu. Is there a solution, or you need to adapt depending on the country?
I would say the more regional elements of that is, for instance, in the States. So yes, every country or every region will have, of course, regulation around frequency transmissions, right? So this is basically the people that are monitoring that you don't go out of the frequencies. And every region also controls the bandwidth in order to give you access to the bandwidth in order to transmit something. So as an example, in the USA, there has been big discussions about ligado. Well, what's ligado? Ligado is a frequency that is also operating very near the GNSS frequencies, and they say, no, we will not affect the GNSS frequencies, while many other people said, no, yes, you will affect the frequencies, you will create interference, harmonics or anything around that. So that's where we see some of those elements, and that we have to keep monitoring, because if ligado will become a reality, as an example, then that means that we have to be also making sure that we are quite protected. By the way, we have tested ligado as well, just to make sure. They have tested as well that in our receivers, but our receivers were quite well protected, so that's what they were using in order to say that the systems were protected. Well, of course, we know that in reality there are many low-end receivers out there, so it could disturb a lot of other systems. So that element is an important one. The regional part, of course, is also in the. So I mentioned the Norway test, but we also do defense testing. So the defense departments of different regions, they invite you to do some jamming and spoofing tests. Those results we cannot show because they have them more quite privately owned. But yeah, that's also something we monitor, and yeah, it happens in Holland, it happens in the USA, Japan, and other type of countries as well. So those are the other elements. Which other things? I would say those are the most important things that could be linked to that. And yeah, you have, as I mentioned, OSNMA, that's Galileo, right? So for the American people, they are not very linked to OSNMA, so that's why they prefer to have other type of solutions. America is moving to a lot to alternative positioning navigation systems, so that's where LEO is an alternative on that, rather than authentication of the signals. They prefer to have backup systems.
In Europe, we're working on backup systems as well in the European Commission, right? As an alternative.
True. I think that's just starting in Europe. but yes, I think in Americas they are quite ahead of that. There are companies like Satelles, companies like Xon, etc., that are already bringing these terms of alternative PNT. NAV, I forgot the name of the company. NextNav, indeed, NextNav as well. So there are several companies that are bringing technologies in that respect because it's a mandate from the government. So it's not because they wanted to exist. It's a mandate from the government to put alternative technologies there. That means alternative, not as a replacement, but as complement to GNSS.
Yeah, exactly. Any other questions?
Thank you.
No more questions? Yes, that
Have a
yes.
question. Oh, yes. So
Sure.
regarding the setup that you have shown us with the HackRF and your Mosaic receiver that is cable connected, I was wondering, is that safe? Is that legal? You can do it freely. And why is this is first question, and why is it important to also have the analog part of the signal that you have said that you could record in the Norway test?
So the first question, is it legal? As long as you don't affect other systems, so you can control the power. So how we do it, we control the power to make sure that we don't we don't go out of certain area, or we are in a more isolated place where we do this type of tests, and that's how we do it as well ourselves. Buying an SDR, by the way, is not illegal. That one you can buy legally. Jamming is illegal. Spoofing as a concept is illegal, but buying the device is not, because the SDR you can use it for different purposes. Actually, you can use it as a simulator for signals, etc. So that one you can buy quite easily online. But the jammer, it's illegal. So a jammer, it's by itself already a device end product. So that one is illegal. So the SDR, we can still use it as long as we don't create, of course, problems around there. So there is a lot of legislation in jamming. I don't think there is a lot of legislation on spoofing yet in that respect. Yeah.
Good,
And then
good.
the second question that you had was why do we record the data? So in a GNSS system, and I'm pretty sure that you have seen that already with Eduardo, but you have different levels, right? The first thing that you do is you have this analog signal that is coming to the front end of the receiver itself. After the front end, you already have some digital information. So at the moment that you have that information digital, then it's already like that. You cannot really do a lot. You cannot really replay it. You can replay it, but not in the same way. If you manage to replay the analog data, then you can change the way your hardware tracking loops are operating. So then you can also play at the deeper level of the firmware of your tracking loops in order to see how to improve your jamming and spoofing side. So this is also quite interesting. You can change also, of course, multiple parameters behind it. As an example, one of the things we do is what we call normally continuous regression testing. So we have several software engineers. They are changing the software every day, making changes there. So you want this to be tested every day, right? All the way, not only the software side, but all the way to the hardware level. So if you can replay the signal in a continuous integration system, then this is magnificent, because you are replaying and retesting what we did in Norway in a daily basis.
Okay, thank you. Thank you.
Regarding Septentrio receivers, as far as I know, you don't have airborne receivers for aviation, right? Which are certified receivers and so on. Are you you have? Yes?
No, we don't. I think Septentrio started at some point at chipset, but certification of receivers is indeed a very complex process. It takes you years. I mean, the GPS receivers that are in the airplanes, they are 20 years old or something like that. It takes several years before they are renewed due to the safety concerns, of course, there. What many pilots are doing, by the way, is they have, of course, a navigation standard system, which is an old system, but they are bringing devices to the plane, which are having tracking of other newer signals. They don't have to be certified, but they use these systems also as an extra visualization element of positioning side.
What do you mean? That you have to have some receivers for this backup, let's say, information?
We don't do those receivers, but some of our integrators are making those receivers, which is also sometimes Garmin is making those. By the way, companies like Garmin or companies like Bat Elf, they make this type of devices that the pilots can have in their plane, kind of what you do in your mobile phone in your car, right? And they give you a position which is more accurate because instead of using single frequency, you use more frequencies, and then you, of course, also have more reliable information behind it. And then what the pilot does is compare all the different navigation systems. They have many other navigation systems, as you know, so they use that. But so no, Septentrio doesn't have a certified aviation product. Not even for defense, by the way. Defense is also a certified type of products a lot in especially in America, which is called SASM type of receivers. But we see that the defense market is moving away from certified because the drones are now becoming smaller to use rather than the big drones, expensive drones. People are moving to cheaper drones.
And what about the automotive industry, the autonomous cars and so on? Yes, you need a
Auto, yeah, you also need a certification. We also don't have a certification because that's also a complex a process for automotive. ASIL is called. The interesting part is that nobody is yet there at that level of safety in the automotive market, and we are already integrated in one of the automotive cars actually out there. Using our technology because they trust more our technology rather than the certified technology. So it's going to evolve, and definitely the certification in automotive most likely will remain as a requirement. But some of the California type of companies, they don't care, and they just say, okay, we want the best technology, and they go for that rather than for a certified approach, which will be more the German approach of automotive or the Detroit type of approach of automotive.
Do you have agreements with Swift Navigation, for example, for a kind of automotive solution, right? Based on corrections and PPP and so on, right?
Well, we have definitely partners in the correction side with SwiftNav, Point One, uBlocks, including Topcon. So those are our partners. By the way, there is a webinar upcoming about that on the 21st of March. So you are all invited. I think it's going to be very interesting in terms of understanding the different corrections mechanisms. So join us. You go to the Septentrio website and subscribe. With SwiftNav, we basically partner, but not necessarily for the automotive. We partner for a lot of emerging applications behind. So can be robotics. There's a lot of robotics, survey mapping, GIS, agriculture, and other type of markets.
I'm thinking about, these applications like aviation or, these vessels, which needs the high certification you are not involved in, let's say, but you have very good methods for anti-attacks. I mean, like spoofing and so on. Are you planning to help them to use this kind of anti-attacks approaches?
Yeah, it's a good point. Today, we most of our marine market is more on the construction marine side because they have been using low-end GNSS receivers for many years. But I think the concerns are growing quite a lot in the marine market as well, especially because that's a place where you see more spoofing and jamming. If you take a look at the events, so that might change. That might change in the coming years, I would say.
Okay, that's a good. And for aviation as well, I guess. I think it's a
aviation for this add-on type of GNSS receivers, yes, for sure. And but yeah, it's a very slow market. Marine is more dynamic, but aviation is very slow market to bring new technology.
Okay. Anyway, thank you so much, Gustavo. It was a very interesting talk. I think we can just stop now here, right? If you have any questions, maybe later you can just send me the questions and I will forward to Gustavo. Maybe are you looking for some interns in Septentrio for working on your spoofing algorithms and so on? We have a lot of telecommunication and aerospace engineers here looking forward.
True, definitely. So yes, actually this year I already have my interns already. But anyway, if you have an interest, just go to our website and we might find an internship. There are some internships indeed open, and some of them are related to spoofing, by the way, and jamming. So yes, feel free to take a look at our website, and definitely are cool internships in that area. Yeah.
Good, perfect. Okay, guys, have a good night all. Thank you so much, Gustavo, again.
Sure. Bye-bye.
Thank
See you,
you.
everybody.
Thank
Have
you.
a good night.
Bye.
Thank
Thank you.
you.
Bye. Thank you.
Bye.
Bye.
Thank you. Good night.